Assalamualaikum warahmatullahi taala wabarakatuh, and good morning to sir. Today my group, uh, which Amirul Daniel Hakim bin Samsul Nizam, Fiza Shazwan bin Fazil, I Muhammad Izzuddin bin Muhammad Shahidi, Muhammad Hafizuddin bin Zuhair, and Muhammad Izzat Khair bin Khairul Anwar to present about continuous variable valve duration (CVVD). Okay, introduction of CVVD. Hyundai recently introduced a new piece of engine tech into its lineup called continuous variable valve duration. Similar to variable valve timing or variable valve lift, it physically alters the way the valve operates within the engine. CCVD works exactly as it sounds. It's a system within the head that can alter how long valve stays open within the combustion cycle, allowing for more or less air to travel in and out of the cylinder, depending on the engine's RPM. Using a specially designed camshaft that can alter the position of each cam loop relative to its shaft using an actuator attached to the motor, optimized to work at every single part of the RPM range, rather than just two chosen points, which is how variable valve timing and variable valve lift work. Next, allow for a 5% improvement in economy, a 4% increase in performance, and a 20% decrease in emission. That means CCVD is a new type, latest from 2019 by Hyundai Sonata. Okay, next, uh, this is an engine about CVVD, continuous variable valve duration. So I continue to the history of product CVVD. In 1993, MG Rover developed a 1.4 LK series engine with a variable valve control (VCC) system, which was the first production continuous VVD system. It is based on an eccentric rotating disc to drive the inlet valve of every two cylinders. Sign eccentric shape creates non-linear rotation. The opening period of the valve can be varied by controlling the eccentric position of this. The concept was developed by Mitchell, and it was published in patent book in 1973. In this design, the control is purely to vary the valve duration, which the valve lift feed, thus different from variable DVVL or CVVL design. The next one, the first engine of Hyundai company is Smart Trim G1.3T GDI. The first engine to feature the technology. The valve control technology regulates the duration of valve opening and closing according to driving condition, achieving a 4% boost in performance and a 5% improvement in fuel efficiency. In addition, the technology cut emission by 20%. So, engine CVVD is also can saving fuel and get more performance to drive. Okay, next, engine valve and why they are important. The first, engine valve are either for intake or exhaust. The intake valve open during the intake stroke to draw the fuel oxygen mixture into the combustion chamber. The exhaust valve open during the exhaust stroke to discharge the expand and oxidate gas out of the combustion chamber. Engine valve open and close in less than 0.02 seconds and undergoes about 100 million cycles in the engine lifetime. Although the open-close cycle occurs in a couple of hundred of a second, the cycles are important determining factor of an engine power. This is because combustion requires a certain ratio of oxygen from the air, which can enter and exit only through the valve. The turbocharging technology that has become commonplace in engine is based on forcing in or charging the combustion chamber with an extra gas of air. This technology about CVVD by timing and lift. As you can see, the first truly innovative valve technology was presented by Porsche more than a century after the first combustion engine by Carl Benz in 1886. The automobile variable valve timing technology by Porsche was called VarioCam. Continuous variable valve timing (CVVT) is a valve timing technology that controls the timing of a valve lift event and is often used to improve performance, fuel economy or emission. Okay, if you look at the picture, you can see the different open and close valve in second. That means you can see the white graph is either for normal engine, okay? But at high speed valve open early than low speed because can reduce emission and that improve performance, okay? So CVVD technology give control over residual exhaust gas within the combustion chamber. When operating at high speed, the technology open the intake valve during the middle and end of the compression stroke. There is a moment of overlap where the intake and exhaust valve are both open, called valve overlap, allowing the maximum expulsion of exhaust gas from the combustion chamber, minimizing residual gas. This gives a great power boost when operating at high speed. For operating at lower speed, the intake valve can be closed later. Early intake valve closing during the intake stroke increase the volume of a fuel mixture. Engine output increase. On the other hand, like intake valve closing during the intake stroke decrease the volume of mixture in the chamber. And if fuel injection is decreased to match the decreased volume, the engine output decrease. In load operation condition, this can improve fuel economy by reducing pumping loss. Power need to compress air inside the piston and the volume of fuel injected. Okay. Pumping loss is the power required to perform intake and exhaust pumping function. For example, take a finger where pressing the plunger in while blocking the injection tip is met with more resistance than blocking the tip mid-plunge. CVT is standard in virtually all automobile engine. The second innovation in variable valve technology came from BMW in 2001 under the name Valvetronic. BMW technology was a continuously variable valve lift system or CVVL, which varies the height a valve open. The technology is exclusive to a limited automakers, which right to the CVVL partner, such as Hyundai Motor Group, BMW, and Toyota. The Hyundai Motor Group independently developed a 2.0 liter gasoline CVVL engine in 2012, which debuted with the 7th generation Sonata engagement model. Okay, that is my introduction and history about CVVD. The next, my friend explain about theory of operation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I want to share about theory of operation continuously variable valve duration, or we call it CVVD. First of all, this CVVD